proceed the introduction of you, sir.
Yes, ma'am.
So welcome, sir. We are from Department of Computer Science Engineering, Sri Vishnu Engineering College for Women. First of all, I like to convey my thanks to you, sir. Join with us to share your knowledge. Before entering the session, first let me introduce about you, sir, with your permission. It is my It is my honor to introduce Dr. Sunny Sharma. Presently, Dr. Sunny Sharma serves as Assistant Professor at Kathuwa Campus, University of Jammu, J&K. Sunny Sharma received his bachelor degree in Computer Application from University of Jammu in 2014 and Master of Computer Applications from Chandigarh University in 2016. He received a PhD in Computer Science from Arni University, Himachal Pradesh in 2020. He has more than 6 years of research experience and 3 years of teaching experience. He published more than 20 research papers in international journals and conferences of high repute. His research areas of interest include machine learning, deep learning, information retrieval. Really, it is our great honor to have Dr. Sunny Sharma as a resource person. Now I request you to share your thoughts in this PPT, sir. Please proceed, sir. Sunny Sharma, sir.
Yes, ma'am. Yes, ma'am. Sharing.
Please proceed, sir. Oh, okay, sir. Dear participants, now we are posting the attendance. Please post the attendance.
Madam, sir has joined, it seems to be.
Yes, sir. Yes, sir. Sharing.
Is being visible?
Yes, sir. It is visible.
Okay, thank you. So thank you, ma'am, for such a nice introduction. And dear participants, good afternoon, everyone. And first of all, let me tell you all, I am recently awarded my PhD. And while my PhD, I published 22 research papers in Scopus and SCI research journals. And I published 4 patents. And I hope till now everyone has learned about machine learning algorithms, machine learning technologies, especially in this 1 week FDP on recent trends in artificial intelligence.
Sunny Sharma, sir.
Yes,
Sir,
ma'am.
please share your PPT, sir. Okay, sir. Now it is. Yes, sir. It is visible now.
Okay, ma'am. Okay. So in this particular lecture, we are going to learn how machine learning algorithms are useful in information retrieval. So my title is Machine Learning in Information Retrieval. As we know all, we have lot of information available on the internet. So it is very complicated to extract desirable information from the internet. So at that time, search engines like Google, we have Bing, we have Yahoo, and machine learning techniques can play important role to retrieve valuable information. If we talk about how much information is available on the internet, we can say, well, the exact number of websites keeps changing every second. There are well over 1 billion websites on the world wide web. Similarly, as you know, a web page is different from a website. Web pages are compound parts of websites, and sites usually consist of one or more web pages. The actual size of web pages seems to be more than 50 billion. So we can say we have large amount of data on the internet. So in order to retrieve the information from these websites, web pages, we need to make use of information retrieval systems. Like we have search engines. In search engine, we have Yahoo, we have Google, we have Bing, we have DuckDuckGo. So many search engines we have. Before discussing how does our information retrieval system work, let's know more about web and generations of the web. So till now, we have three generations of the web, right? We have first generation of the web, second generation of the web, and third generation of the web. So first generation of the web was the first implementation of the web, and it lasted from 1989 to 2005. The role of the web, first generation of the web, was very passive in nature. So there were so many limitations in first generation of the web, like we can say we can understand first generation of the web with the help of an example, like we are reading a newspaper, right? We are not able to conversate, we are not able to make a discussion with the author of the information. Even we are not able to communicate with another reader of the same informations. So these were some limitations of first generation of the web, which were removed in second generation of the web, right? So what there were also some limitations in second generation of the web, like there was the data was not in structured form, right? There was no role of machine learning web, second generation of the web. So we can also understand the second generation of the web with the help of some examples, like we have Twitter, we have some blogging websites, we have Facebook, we have some other websites, like we have YouTube. So all these are uh, so all these are applications of second generation of the web. Here we can make discussions with everyone. We can have discussions with our friends. We can make discussions even our students. So these were some there were some advantages in second generation of the web, but as I discussed earlier, there were also some limitations in second generation of the web, like there was no role of machine learning, there was no role of semantic web. So these are some limitations in second generation of the web. Obviously, these limitations were removed in the latest generation of the web, that is third generation of the web. So the main idea in third generation is to define structured data and link them in order to make effective discovery, automation, integration, and reuse across various applications. Actually, the idea was to make the information machine understandable by incorporating machine learning technologies. So this was the main idea behind third generation of the web. So in this particular lecture, in this particular section, we are also looking forward to discussing how machine learning algorithms are being used in information retrieval. So as time passed by, search engines became available, which employed a variety of techniques in order to extract the required information from the web pages. These techniques are called web mining. Formally, web mining is the application of data mining techniques and machine learning to find useful information from the data present in web pages. Web mining is categorized into three parts: web content mining, web structure mining, and web user mining. So this is the web content mining. So web content mining is very similar to text mining and data mining. As I have written here, web content mining deals with extracting relevant knowledge from the contents of a web page. During content mining, we totally ignore how other web pages link to a given web page or how users interact with it. A trivial approach to web content mining is based on location and frequency of keywords. For example, I put some keywords on search engine. For example, I put Apple on search engine. I will be provided all the web pages containing the keyword Apple. So this is a very basic example of web content mining. Next, we have web structure mining. It is a tool used to identify the relationship between web pages and how the web pages are interlinked with each other. So there are so many algorithms used in web structure mining, like we have page rank algorithms, which is used by Google to find the ranking of web pages. Next, we have hits algorithms. Similarly, we have better page rank algorithms. We have Alexa. So all these algorithms which are used in web structure mining to find the relationship between web pages, how the web pages are interlinked with one another. Next, we have web user mining. It tells the identity of a user and his browsing behavior on the web. With the help of it, we can identify a user by using IP address, cookies, or login authentications. So these are the basic tasks that are performed in web user mining: data collection and pre-processing, pattern discovery, pattern analysis. So if we discuss, like with the exponential development of reachable information on the web, the results demanded by web clients provided by traditional web crawler has hardly meeting efficiency, effectiveness, performance. Even they are based on good algorithms, trained document indexing techniques, or sophisticated algorithms. Like we can have an example like the word apple, right? Apple has two meanings, either a fruit or the technical term. Like I discussed in web content mining, we can search apple keyword on the Google or any other search engine. Like the search engine will provide us all the results, all the web pages having the keyword apple. But at the same time, the search engines can be confused, right? The search engines can be confused what the results they have to provide to a particular user. For the keyword apple, apple can either be a fruit or the technical terms. So at the same time, in order to remove these type of confusions, we need to exploit machine learning technologies in information retrieval. So this is our actual title. So this is our actual topic that we are going to discuss in this particular sessions. So machine learning and web user mining, how machine learning is being used in web user mining. The overall process is divided into three main phases. First, we have learning phase. we have matching phase, we have the last one is recommendation phase. So first of all, whenever we have to employ machine learning in web user mining, the overall conclusion will be we have to predict the behavior of a user, right? Whenever we are employing machine learning in information retrieval, either in web user mining or any other process, the overall conclusion will be we have to predict the behavior of a user. So obvious reason is we need to collect the past behavior of that particular data. So this is the first phase, that is learning phase. In this phase we will whatever we are going to do means we are collecting the behavior of a particular user. Based on that data in the future we will predict the behavior of that user. So this is our first phase, that is learning phase. In this phase we will collect the behavior of the data. So the data can be collected in two ways, that is first one is implicit learning and second is explicit learning. Okay, so in implicit learning, sorry. So in implicit learning, the system automatically collects the behavior of the user. Whenever a user is surfing on the internet, whenever a user watching some videos, the system automatically collect the behavior of the user. What a user is watching, what a particular web page is a user is clicked on, how many times a user is investing on a particular web pages. So this is all about implicit learning. In implicit learning, the system does not ask the user to submit the information, whereas in explicit learning the system explicitly asks the users to submit the information by some forms, right? There can be some authentication forms. The system can ask the user uh, to log in by username, passwords, some kind of information like his date of birth, his many other information, right? In explicit learning, basically in explicit learning, the system explicitly asks the user to submit the information, and in implicit learning, the system automatically collects the information about a user. So in matching phase, whatever the data we have collected in a learning phase, in matching phase, we use machine learning algorithms like collaborative filtering, content-based filtering, rule-based filtering, and hybrid filtering, right? In second phase, in matching phase, we use machine learning algorithms on the data we collected in first phase, right? Based on that data, we try to predict the behavior of the user. And in the third phase, we provide personalized recommendations. We provide personalized results to the users. So let's understand how collaborative filtering works, how content-based filtering work, how the hybrid filtering algorithm works. So first we have collaborative filtering algorithm. So the basic assumption of collaborative filtering is that people who had similar taste in the past will also have similar taste in the future. One of its earliest definitions is collaboration with people to help one another perform filtering by recording their actions to documents they read. So this filtering algorithm can also be understood by this diagram. Here we can see there are two candidates, Alice and Bob. We can see here in this picture, Alice and Bob both like a mutual movie, right? It can be anything. So both Alice and Bob are liking a mutual movie, right? We can say both have similar interest, both have the same kind of profile, both have the same kind of past profile. So based on this behavior, we can recommend some items to them in the future. Like here you can see Alice is liking another movie, right? And at the same time, that particular movie is being recommended to Bob. It is all the main idea behind collaborative filtering algorithms. We can also understand collaborative filtering algorithm with another example, like, so here we can see user U1, user U2 like the movie 1 based on their ratings given to movie 1. Like user 1 is giving a rating to movie 1 5 rating. Similarly, user 2 giving the rating movie 1 as 4. So we can say both these users like the movie 1. So these users have the same taste. Now, in the user 1 like the movie 2 because he has given the rating 4 to movie 2, right? Now user U1 likes the movie 2, again he has given the rating 4 to movie 2. So user 2 would like the movie 2, right? This is a flow of logic how a collaborative filtering algorithm work. Here here we are finding a semantic similarity. You can say we are finding the similarity between users, and based on that similarity, suppose we are recommending items for the particular system. Next, we have content-based filtering. Content-based filtering is based on the assumption that people who liked items with certain attributes in the past will like the same kind of items in the future as well. It makes use of item features to compare the item with user profiles and provide recommendations. Recommendation quality is limited by the selected feature of the recommended items. So we can understand content-based filtering algorithm with this example. Suppose, suppose we have 4 items here, as you can see in this picture. We have 4 items in this picture in which the user starts liking only 2 movies, only 2 items, item 1 and item 2 at first, right? I'm repeating it again. Suppose we have 4 items in which the user start liking only 2 items at the first, item 1 and item 2. Similarly, third movie, or we can say the third item is similar to first movie, the first item, right? The third item is similar to the first item in terms of actor, actress, movie nature, genre, etc. Right? So the system will automatically suggest the third movie, the third item automatically to that particular user. It is something that is automatically generated by content-based recommender system based on the similarity of content. So this is the main idea behind content-based filtering. Here we are finding the semantic similarity between items. Okay, in content-based filtering, we are finding the semantic similarity between items. What in case of collaborative filtering algorithms, we were finding the similarity between users. So this is the main difference between these two algorithms. In case of content-based filtering algorithm, we are finding the similarity between items. In the case of collaborative filtering, we are finding the similarity between the users. So these are the main machine learning algorithms which are being used in information retrieval systems. So the same example which were we used in earlier, like Apple, right? The same example, the same ambiguity can be removed by using these two algorithms. Like, okay, we can find the, for example, as I earlier said that apple can be have two meanings, either a fruit or the technical term. Okay, like the python can be have two meanings, either a programming language or that a particular breed of snake. Okay, so all these are ambiguity keywords. So this ambiguity can be removed by exploiting web user mining, by exploiting these algorithms. Okay, we can study the past behavior of a particular user, and based on that particular behavior, based on that past behavior, we can understand the meaning of Apple. We can understand the meaning of Python. Uh, there are also many other ambiguity keywords. Okay, so we can remove this ambiguity by exploiting machine learning and information retrieval. So despite the huge success of recommendation techniques, these techniques suffer from several limitations, like there are so many challenges which are associated with the collaborative filtering. These are cold start problem. We have sparsity, we have scalability. Okay, so there are some challenges which are associated with the CF algorithm, that are cold start problems, sparsity, and scalability. In cold start problem, for example, we do not have data about a user. We don't have past behavior of a particular user. At that time, we cannot predict the behavior of that user. So this is known as cold start problem. Okay, next is sparsity and scalability. When we have large amount of data, okay, we have large amount of data, it means we need to have powerful machines. So these are some problems which are associated with these machine learning algorithms. Uh, so new scholars and new researchers can work on these problems, on these research gaps, to have good publications. Similarly, there are also some problems which are associated with content-based filtering, like we need to perform over specialization. We need to perform content extraction problems. Again, there is a sparsity problem. So these are some problems which are associated with these machine learning algorithms. So these are some of my publications which are published in Scopus and SCINers. And so thank you all the participants for having patience.
Participants, if you wish to interact with the professor, you can please unmute yourself and can interact. Gayatri ma'am,
Okay, sir. Thank you, DrSunnySharma, sir. It is very excellent session. Initially, you started with the general.
CSF की 8 మళ్ళీ CRPF की 1350 DK की 10 అదే ఉన్నారా మొత్తం కలిపి పోస్టులు 3370.
So really, it is very useful to all the research scholars and faculty members, and they helpful to how machine learning is related help in the web usage mining, sir. Thank you very much, sir. Have a nice day, sir.
Thank you, ma'am. Thank you so much. Thank you, Kiran sir.
ये पूरे हिंदुस्तान में परिचित हो गए जब आप
thank you, sir. Thank you, Dr. Sharma.
Thank you, sir.
Thank you, sir. Have a nice day. We'll collaborate in our future endeavors also. Thank you.
Definitely, sir.
Gayatri madam, the next session will start exactly at 5 o'clock. We can announce.
Dear participants, the next session can start at 5 o'clock. Please be available at 5 o'clock.
ఈరోజు మండే చేసి మండే మార్నింగ్
నుంచి 5.
Hello, sir.
Yes, sir.
Ma'am, when will be the exam?
At 7 o'clock, sir.
7 o'clock. So you'll post the link at 7 o'clock, yeah?
Yes, sir.
Okay, thank you.
మేడం ఆ స్లైడ్ పెట్టేసేయండి 5 o'clock అన్న స్లైడ్ ఉంది కదా ఆ స్లైడ్ పెట్టేస్తే మనం యూ కెన్ టేక్ ఎ బ్రేక్ ఫర్ 30 minutes.
చూస్తున్నాను సరే.
Okay.
आज बजे स्टार्ट
లేదు ఇక్కడ వాళ్ళే మూవ్ చేసుకుంటారు.
Dr. Bindu Krishnan. Madam, good afternoon.
Yeah, good afternoon, sir.
Good afternoon.
A minute.
Madam, we'll start the session in 5 minutes, madam.
Yeah, okay.
Madam, you are academician initially, then transformed to industry, what, madam?
Pardon?
You are the academician initially, and then you went to industry, what?
Yeah. It's just a job transition.
Transition.
Yeah.
So what is the general difference that you have observed in this academicians and
No,
this
actually,
industry?
it's only because of my passion towards this artificial intelligence and machine learning.
So
So,
is there any,
is it audible, my voice?
your voice is audible, madam, you are also visible. Then
Yeah. Okay.
But what about the trends, madam? Do you find any recession now in this particular period?
Actually, at present, my job role is just a research-oriented work. So, and also it's a combination of statistics and AI. So that is why I took a step towards. Because actually, after my PhD only, I have basically my subject is statistics. After doing the PhD only.
अरे हमारे तो कहाँ यार फ्लेक्सी पूरनपुर माँ क्या करे उसे मंगा लो ना.
Just a minute, madam. Somebody is talking.
It's okay.
ये लोग माँ
Because for the last few months, I'm just hearing that there is a recession and the number of jobs are decreasing, something like that. I'm just to validate that I have asked.
Yeah. Basically, my that job role. That's why I was very much interested, because it's a combination. As I said, after my PhD only, I have done this MTech artificial intelligence. So I got an opportunity to work as just a combination of these two things: AI implementation in statistical software. So that's why I have decided to. Usually, it's rare. This academics to industry is very rare. I know that.
It's very difficult. That is the reason I asked. Like the transition is very
definitely. I have taken it as a challenge.
Challenges. So your interest is that.
Because industry to academics is common. Usually, maybe especially after the age of 40, 45, usually people
to come back.
To come back. So I just took the reverse of that. Definitely, it's a challenge. No doubt in that.
Gayatri, madam, we can start, madam.
Yeah, okay. Sir, my allotted time is 40 minutes, right?
Yes, madam. We'll close exactly at 5:40.
Okay.
Madam, please proceed. Gayatri.
Okay, sir. Welcome back to Faculty Development Program. Welcome, Bindu Krishnan, madam. First of all, I like to convey my thanks to you. Join with us to share your knowledge. Before entering the session, first let me introduce about you, madam, with your permission. It is my honor to introduce Dr. Bindu Krishnan. Dr. Bindu Krishnan is currently working as Senior Statistician, Data and AI in IBM Research and Development Software Labs, Kochi, Kerala. Prior to this, she served as the Professor and Head of the Department of Data Science, Computer Science and Information Technology, Jain University, Kochi, Kerala, and as Associate Professor and Assistant Professor in various institutions. She has more than 20 years of experience in academic and research. She achieved a PhD in statistics from Bharatiya University. Her master's degree in statistics from Cochin University of Science and Technology and Master of Technology in Computer Science and Engineering, Data Science and Artificial Intelligence also from Cochin University of Science and Technology. She had published a book with the title Probability Distributions, Random Process and Numerical Methods. She published several research articles in reputed journals, national, international, indexed journals like SCI, Web of Science and Scopus journals. She had delivered a number of innovative sessions as well as hands-on sessions, particularly in data science, machine learning, artificial intelligence, etc., using various programming languages. Her major area of research interest including distribution theory, time series modeling, data science, and machine learning. Really, we are very happy to have such talented person as resource person in this 1 week national level online FDP faculty development program. Now I request you to share your knowledge. Madam, please proceed, madam.
Thank you. Thank you. So thank you for the nice introduction. And
Thank you.
okay. So at the same time, I express my sincere gratitude to Kiran sir and team from Sri Vishnu Engineering College for Women for the opportunity given me in delivering this session. So my allotted time is 40 minutes, right? Am I right?
Yeah. Yes, madam. Yes.
You know, so as like this machine learning and artificial intelligence, say speaking few words in with this limited time, it's very difficult. So, but definitely I will stick on my time. I'm thinking of to yesterday actually I just messaged to Kiran sir. Is there any specific preference for that topic? As sir said, no, there is no preference. But I know this is an online 1 week FDP in artificial intelligence and cyber security. So artificial intelligence, as we all know, there is no AI without machine learning. Of course, machine learning is a core part in especially in academics, I can say. But AI is not fully stick or to machine learning. And I'm thinking of to spare this 40 minutes, upcoming 40 minutes, to give you all. And I hope all of the participants are teachers, right? Am I right, sir? Almost all participants are faculty, right? Teachers?
Yes, madam. Everybody is faculty. Yes.
Okay. From computer science background or heterogeneous group?
Yes, it is a heterogeneous crowd, madam.
Okay. Okay. So I think it's better to keep a basic level itself. Okay. So I'm thinking of to give you, of course, I'm basically a statistician or my PhD in statistics, and additionally I have taken this MTech in computer science. Specifically, that specialization is data science and artificial intelligence. So I'm thinking of to give you the importance of statistics in machine learning or AI. Because simply saying, of course, we all, especially computer science teachers, know that. We can say there is no machine learning without statistics. No doubt in that. So I'm thinking of to give you a brief idea of why this what is the role of statistics in machine learning as well as AI or in security, cyber security also. Let me share the screen. I think should I off the camera so that network could be more.
Yes, madam. That will be good.
Yeah.
Yes.
Is it visible, sir?
That's not visible, madam.
Yeah. Okay. Thank you. Let me make it a full screen. Okay. So, so in this talk specifically, I'm going to stick on these two words, machine learning and statistics. And in between, definitely this machine learning is a subset of AI. But before moving to these two words, let me start with the word that connects these two things. That is data science. That's the word that connects the two. So data science, all these things actually, I can say the statistics also part of data science, or a core part of data science lies in statistics. Core part lies in machine learning. So data science, of course, it's a combination of data analysis, algorithmic development, then technology, etc., 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 in order to solve some analytical patterns, analytical problems. No doubt in that. Or I can say it's a science of using data to build models that lead to better decisions, which in turn add values to individuals, companies, organizations, institutions, and so on. Then what is the role of these two words there in data science? The field of data science includes the art of machine learning, artificial intelligence, etc. And statistics can be a powerful tool while performing the art of data science. So that is the role actually of these two words in data science. Statistical technologies are tools actually that enables us to answer questions about patterns in empirical data. But machine learning is about predictive models from uncertain data. And one important thing that we use in machine learning is probability. I can say probability is the heart of machine learning, or probability is the bedrock of machine learning. Those who are aware of machine learning in this group, definitely those teachers are very much aware of the role of probability in machine learning techniques. Whatever algorithms which we handle, definitely that basis will be the probability, where the probability is a branch of statistics. Or we can say the probabilistic methods are the heart of machine learning, no doubt in that. So as we all know, of course, machine learns from experience or past data. But how can a machine learn from experience? So let me start with some basics of machine learning. Then I will move to that. I'll focus to the exact role of this statistics and mathematics in this area, machine learning. Okay, let me start with the machine learning itself. Machine and learning. So this is a brief overview which I am thinking of to deliver in this 40-minute session. Okay, so two words are there, machine and learning. Of course, machine stands for some apparatus that can perform any kind of task, like a computer, printer, and so on. But when we add learning to this, after it, together it means how a machine learns. Definitely this machine learning is rapidly changing the world from diverse set of applications and research, both in industry and academia. Now move on to the previous question, how can a machine learn? A simple example. Say, suppose I take one of you to a pet shop, which has four dogs and 4 cats. And if I teach you which of them is a dog and which of them is a cat. A simple example. Many of you are, I know many of you are aware of this, but just let me, since it's a heterogeneous group, that's why let me start with that overview of machine learning itself. So if I take one of you to a pet shop that has 4 dogs and 4 cats, and if I teach that person which of them is a dog and which of them is a cat, after that, if I bring in a different breed of dog, which is not present in the previous sets of dogs and cats, previous sets of 4 dogs and 4 cats, then you can predict that it is a dog. But how? Here I didn't teach you that the new breed of animal is a dog, but you were still able to predict that it is a dog because you were already taught previously from the previous 4 sets of dogs and 4 sets of cats. So the machine works in a very similar manner. The first set of animals, that 8 animals, 4 dogs and 4 cats, are equivalent to training data because those data is used to train for training. You have used that data for studying. Or I have used that data to teach you which of them is a dog, which of them is a cat. So that is known as training data because it is used for training the machine. Then the second one, that other breed of dog, that is equivalent to test data. That is, I am testing whether you studied it or not. So that we call it as test data and is used for testing our machine. So machine learning is actually, a machine works in a similar manner. It's concerned with a development of techniques or algorithms that are able to learn. That is to improve automatically through experience. There are so many definitions for this machine learning we can see in literature. So one common definition is the first one, field of study that gives the computers the capability to learn without being explicitly programmed. What do you mean by that? Learn without being explicitly programmed. That means we are not going to teach the computer with a specific set of rules, but instead, what we are going to do is feed the computer with enough data and give it time to learn. Definitely by making its own mistakes and improve upon those. Then one more real instance I can say for this machine learning. Every day we recognize our family members and friends. How? Simply by looking at their faces or from their photographs, despite their differences in hairstyle, pose, lighting, etc. But actually we do it unconsciously. And we are not able to explain how we do it. Since we are not able to explain our expertise, we cannot write the computer program. But at the same time, we know that a face image is not just a random collection of pixels. It has structure, symmetric, and there are eyes, nose, mouth, etc. located in certain places on the face. Each person's face is a combination, it's a pattern actually. Combination of these eyes, nose, etc. Now, how to recognize it? Or how to recognize a person or an image of a person by the machine? By analyzing sample face images of a person, that is, we have to pick a sample set of images first to train that machine. So by analyzing the sample face images of a person, the learning program captures the pattern specific to that person and then recognizes by checking for this pattern in a given image. Finally, we will give the machine we will give the machine a test data. One or more images. So finally, it recognizes by checking for that pattern in which machine learned in the given image. So this is an example of, it's a common example of, I can say, face recognition or general pattern recognition. Because the ultimate aim of machine learning is to understand the structure of data and fit that data into models that can be understood and utilized by the people. Or we can say it's a set of models that can automatically detect patterns in data. Then use the uncovered patterns to predict the future data or to perform some kinds of decision making under uncertainty. That's all. But definitely here we use the computers to recognize all these patterns. That is by developing the algorithms, developing the models. So machine learning is actually, we can say in another word, it's programming computers to optimize their performance criteria using some past experience, also using some data, example data. Definitely from that data will be from past experience. And we have a model here. We usually call it as machine learning model. What do you mean by machine learning model? So there actually the role of statistics or mathematics lies behind there. The machine learning model can be a mathematical representation of real world process. To generate this model, we need to provide data, training data to the algorithm to learn from. So while training for machine learning, we pass an algorithm with training data. That's very important. That is mandatory. We are not starting with a set of programs. We will pass some definitely we provide training. We pass an algorithm with some training data. Then the algorithm or this learning algorithm finds patterns in the training data such that the input corresponds to the target. Input parameters correspond to the target and the output of training process. That itself we call as machine learning model, which can be used for future predictions. So this itself, or this process is actually the crux of machine learning or learning. So this we have a model here defined up to some parameters, and learning is the execution of that program to optimize the parameters of model using the training data or past experience, data collected from past experience. And this model, this machine learning model may be predictive to make predictions in the future, or descriptive, that can be descriptive also, to gain some knowledge from data, or that can be both. That model can be both descriptive and predictive. That possibility is also there. Lot of examples are there for machine learning, handwritten recognition. Just I have mentioned only 2 examples, like how to recognize dogs and cats. Then how the face recognition or pattern recognition, that is image recognition. This image is an example. It's an example which I mentioned. Then face detection. So many examples are there for machine learning in our daily lives. So because of this, we can find applications for machine learning in different areas, such as social media, medical field. I can say, yes, pardon.
Sorry.
Any doubt? Okay. So in medical field, actually nowadays I can say that even doctors are using this machine learning technique. Doctors are using machine learning techniques also for prediction of diseases. I'm not simply saying that, even some doctors actually, I have attended many calls, I can say. That is, many doctors even approach me through telephones, just asking me, I say I'm a doctor and I have so and so MD, DM like that. Can you suggest some? They're asking me, can you suggest some courses for prediction, especially in deep learning? Because nowadays, lot of research are going on in deep. Not nowadays, even for the last few years, I can say. So just for an addition, actually, doctors also believe in this machine learning now, machine learning predictions. Then other areas such as finance, marketing, bioinformatics, etc., etc. So applications are there. Now, what is the exact difference between machine learning, artificial intelligence, and deep learning? Artificial intelligence, of course, it's a wide range field of study that's concerned with building smart machines capable of performing tasks that typically requires human intelligence. I'm sharing that definition which you all see in the literature. Building smart machines. That is correct. It is used for building smart machines, but that requires some human intelligence. But what is the difference between AI and machine learning? Of course, this ML is a sub of machine learning. That is, there are some other things also in artificial intelligence. Artificial intelligence actually makes it possible for computers to learn from experience and perform human-like tasks, I can say. But the role of machine learning is to observe large amounts of data and make predictions using algorithms or statistical algorithms, ideally going on to perform tasks beyond what they are explicitly programmed for. Then deep learning is again sub of this machine learning. So the traditional machine learning algorithms actually includes this Bayes, logistic regression, linear regression, etc., etc., etc. While reaching neural network, we can say that we have reached the deep learning algorithm. So that is why deep learning and also deep learning actually it follows that neural network. It's based on the neural network, artificial neurons. Okay. So deep learning is of course subfield of machine learning. I can say it's a new take on learning representations from data that puts an emphasis on successive layers of increasingly meaningful representations. But I'm not going to in detail of deep learning. So just mention the difference between deep learning and machine learning. Now come to the role of these two things, because that is the topic. Why statistics is important, or what is the difference between statistics and machine learning? Statistics and machine learning are very closely related fields. One is the field of mathematics and other computer science. Right? Statistics is the subfield of mathematics. Machine learning is the subfield of computer science. Both are but field of science. Machine learning uses the theory of statistics in building mathematical models that I mentioned earlier. Why? Is that because the core task is making inference from the sample? Right? But the role of computer science is twofold here in machine learning. Firstly, in training, we need efficient algorithms to solve the optimization problems and to store and process the massive amount of data that we generally have. Secondly, once a model is trained, its representation and solution, algorithmic solution for inference, needs to be efficient as well. So for these two things, definitely computer science, role of computer science is required. But the role of statistics is actually this, its main task is to making inference, so that we get only from statistics. Right? The statistical concepts and theory actually that are prevalent in this machine learning includes machine learning theory of machine learning includes regression, then weight, bias models, and so on. Or it would be fair to say that statistical methods are required effectively work through a machine learning predictive modeling project. That word is actually one of the important things connects this machine learning and predictive model, machine learning and statistics. That is predictive modeling. Because this process uses data along with this machine learning process actually uses data along with statistics analysis and actually to create the predictive model for forecasting future events. And again, I can say many machine learning algorithms require statistical background, strong background in statistics and probability. And some researchers refer this as statistical machine learning or simply statistical learning. This machine learning is statistical machine learning, but there is a slight difference between machine learning and statistical machine learning. So I'm not going that way. Just shared you that some others call it a statistical machine learning. So in one word, I can, or in one sentence, I can say the difference between these two things is machine learning is all about predictions, the supervised learning, unsupervised learning, etc. But the statistics is about sample, population, hypothesis, etc. But both statistics and machine learning have the same objective, no compromise in that. I can show you some exact difference between these two things. That is this. This is a field of statistics, field of mathematics, and machine learning, field of computer science or AI. You can say anything. Then this we focus on building models with some programmed instructions. But here we don't have any program prior to doing that. We are creating models or systems that learn from data. Then here in statistics, actually purpose is to make inferences or relationship between variables. And here actually we always heard of these two words, optimization or predictions, predictive accuracy. Then here in statistics, we require some prior assumptions. Say, for example, in regression, we have to assume that, or we have to get that data to be normally distributed like that. But in machine learning, we don't require any assumptions like that. That really a plus point for this machine learning. Then dimensionality of data. Usually in statistics, we do analysis with low dimensional data, low volumes of data, least volumes of data. But in machine learning, it's not like that. We always focus on high dimensional data. Then, but last point, anyway, it's a plus point for statistics. For statistics, no ML knowledge, machine learning knowledge is required, but in machine learning, statistics, knowledge of statistics is required because it's the basis for algorithms. Most of the algorithms, I can say 99% algorithms, that basis is statistics. So this itself gives you the exact picture of the difference between these two, statistics or the role of statistics and mathematics in machine learning. Yeah, some keywords that we used in machine learning as well as in statistics. In machine learning, we use the word instance, and here we use simply the word data point. Then feature, machine learning, we use the word feature, that's a common thing. But here we use the word covariate. Then in statistics, actually, parameters we used, maybe you may be aware of the word normal distribution or Gaussian distribution. And we know that mean and standard deviation are mu and sigma are the parameters like that. But in machine learning, it's not like that. Parameters, especially in deep neural network, weights as the parameters. Then in machine learning, of course, we use the word learning, but in statistics, we use the words estimation, fitting, etc. Then the regression, I can say we use both in machine learning and this statistics also. Then label, another word which we used is label here in machine learning, but in statistics, we use the word response, like that. Then generalization. Here we use actually generalization for what is generalization in machine learning? Best performance. Best performance. But here, instead of that, we use just set performance only. And because in mathematics, as you all know, mathematics generalization means we will come to a general point. That is not the case with the machine learning. Machine learning generalization means that best performance. Yeah. Now moving to the types of machine learning, just a quick overview of types of machine learning also, because there also I would like to stick on to some important points that we require, or that we need to connect these two words, machine learning and statistics. So actually there are 4 types of machine learning, but traditionally we say only these 3 types: supervised learning, unsupervised, and reinforced learning. This semi-supervised is just a combination of these two. Supervised, just I'm skipping that. I'm sticking on to traditional types itself. Then supervised learning, it's a learning in which we teach or train the machine using data. That those 2 examples which I mentioned comes under the supervised learning. That is, we teach or train the machine using data that is well labeled. That is very important here. Well labeled data. Data should be well labeled. That means nothing. Some data is already tagged with the correct answer. Or in supervised learning, actually the training data provided to the machine works as a supervisor that teaches the machines to predict the output correctly. Or we can say it applies the same concept as a student learns in the supervision of a teacher. There is a supervisor there. That's all. In case of supervised learning. So then we have, of course, we have some input variables and an output variable, and we use an algorithm to learn the mapping from input to output. Or we can say the goal of this supervised learning is to approximate a mapping. Mathematically, we say it's to approximate a mapping function. That or mapping function so well that when we have input, that he can predict the output. So mapping function, I use the word mapping function. So that word clearly gives us the relation between machine learning and mathematics, because function is basically a word from mathematics. If you have 2 sets corresponding to every element in the first set, there exists a unique image in it. It's exactly same thing which we take here. Approximate a mapping function. But here we take from input to output, that's all. Or this type of learning, supervised learning, is the task of learning a function that maps input data to output data based on some instances, some examples, or some input-output pairs. And this supervised learning, actually 2 types are there: classification and regression. What is the difference between these 2? Classification models are used, or classification happens when the output is a category. That is, if you want to predict whether it is yes or no, or in the previous example, if you want to predict whether it is a dog or cat, or if we want to predict whether it is on or off. And we need not have to stick on only two options. If we want to predict whether it is high, low, or average, we can have more than two options. So classify, that categories. So there we use classification. Classification problems or classification models are used for problems the output can be categorized. But regression, in case of regression techniques are used when the output is real valued based on continuous variables. What do you mean by simply real values? Simply some values. For example, price of house. If you want to predict the price of a house, or if you want to predict the weight of a person, height of a person, all those things actually numerical quantities, right? So all those things comes under this regression, second type of regression. So that is the exact difference between regression and machine learning. So I'll come to the example, but before that, let me say one or two sentences about the other types of learning also. Unsupervised learning. What do you mean by unsupervised learning? Unsupervised is the difference between supervised and unsupervised is in supervised the data is well labeled, but in unsupervised no labeling of data. It is a training of machine using the information that is neither classified nor labeled. And it allows the algorithm to act on the information without any guidance. There is no supervisor, there is no teacher here. So here the task of machine is to group unsorted information according to similarities, patterns, differences, etc. without any prior training of data. There is no prior training of data. For unsupervised learning is where only we have some input data and no corresponding output variables. And its goal is to actually model the structure of data or distribution of the data in order to learn more about the data. And these two again classifies as clustering, and clustering actually it's a common term even among this computer science group. What is clustering? Clustering is a procedure. Cluster, that word itself, that meaning is clear in that word itself. Clustering, making groups. That's what we do there. Clustering is the procedure for grouping a set of objects into clusters. But there are some conditions for this grouping. That is, we classify the objects into homogeneous groups. Those homogeneous groups we call it as clusters. See, homogeneous group in the sense objects belong to a particular group is having some similar characteristic. So, for example, if you are given simply a combination set of fruits, apple, pineapple, banana, orange, etc., grapes, etc. So how do we apply unsupervised learning there, clustering there? So if it is possible to divide those groups into one group a set of apples, one group a set of oranges, one group a set of pineapples, one group a set of grapes, one group a set of banana. So each of those groups we can call it as a cluster because there is some similarity there. But if you pick a fruit from one group, say apple group, you cannot find an apple in the other group. That means objects in different groups are heterogeneous, no similarity there. That is very important in case of clustering. Objects in the same groups are, of course, there is some similarity there, but objects in different groups are dissimilar. So that's what here this unsupervised learning does. Then another thing is association. That is another type of this unsupervised learning. Association is actually where we want to discover some rules that describe large, for example, market basket analysis. That's an important example of, that's a common example of association. What is this basket analysis? Take the case of supermarket, where one application is basket analysis. Actually, it's finding some association between the products bought by customers. If the people who buy the product X typically also buys Y. That also I can give you an example. Suppose one person with a small kid approaches a supermarket and he is having the aim of buying some say tin food like Far Excel, Lac, etc. So if the person is having the opportunity to buy, or if that supermarket includes the products such as this diapers for kids, such as Snuggies, Pampers, etc. Definitely that customer will buy that product also from the same supermarket. Right? So that if the people who buy X also buy Y, or I can say those people who buy say beer or some liquor types also buys chips, etc. So that tendency is there. So if the supermarket, that owner of the supermarket is able to include correlating items, associated items also, definitely he can increase his profit in crores. So by doing the analysis of that, so that is actually, or we can say this another that itself is the more important common example of and easy understanding for this associated. Now our objective or our aim is what is the relation or what is the role of mathematics or statistics here. Actually in association rule, we use the simple type of probability which we call it as conditional probability. Conditional probability, that is probability based on that itself is the technique behind these association rules. Condition, that is if the people who buy X or sometimes suppose one customer bought say beer or liquor, some liquor. So that is a given condition. Then what is the probability of buying chips given that the customer buys? So that probability of an event given another thing. So that itself we call as conditional probability of an event given that another event that has already happened. So that theory lies behind this association. Clustering, actually, I didn't mention what is the role of statistics in clustering. Clustering, actually, it comes from a branch of statistics known as multivariate analysis. Again, this classification techniques, that is also from multivariate analysis. The one branch is there for statistics, just like machine learning is a branch of computer science or is a branch of artificial intelligence. Multivariate analysis is a branch of statistics. So in that multivariate, the theory of all one, even regression also actually it's a I can say it is more than a century-old method from the field of statistics that is used for fitting a line to real value or a plane to real value data. But from the machine learning perspective, we look at this regression as a system for learning weights or coefficients in response to, because in deep neural network also we are using this regression for making predictions. Then see, yeah, this already I mentioned. Some examples of supervised learning or unsupervised learning I had included. So as I mentioned, in supervised learning, it's a label data. This will be labeled as rectangle, machine, circle, etc. We will pass this to the machine. We will come up with a machine learning model. Finally, we will predict whether it is triangle or circle. But in unsupervised learning, there is no label. See, you are given a set of pictures. Finally, we will classify the pictures into three. This actually, I can say, an example of clustering. This rectangle, circles, triangles, like that. That is the difference between machine learning, supervised and unsupervised. Case of another example for supervised and unsupervised learning. Right? Then third case is actually reinforcement learning. Actually, it is a training of machine learning models to make a sequence of decisions. Or it's about taking some suitable action to maximize reward in a particular situation. So, say for example, here look at this. Here one robot is here. He is having some hurdles in between. Finally, he needs to reach here. So this agent robot is supposed to find the best possible path to get this. He can go this way, or he can go this way, or he can go this way. He has to find the best possible path so as to catch this diamond. So that is an example. Now going to, since that time is going to be over, let me finish. Sorry. So these are the machine learning algorithms. So just in one sentence, I can say all these, the basis of or theoretical concept of all these algorithms lies in statistics, because Bayes is based on a famous theorem known as Bayes theorem. which all of you are familiar with that Bayes theorem. The regression already I mentioned, this logistic regression, then k-means clustering, k-nearest, these are all comes from the branch of statistics known as multivariate analysis. Then decision tree, random forest and support vector machine, actually decision tree and random forest from the graph theory, branch of mathematics known as graph theory. So I can say simply all these algorithms, the basis, the theoretical concept definitely from statistics or mathematics. So I think with that I can stop because my time limitation is over. That's why before beginning the session itself I shared that this 40 minutes is not enough to share about machine learning. Okay, any queries?
Dear participants,
Any
if
queries?
you want to communicate, ask any queries, please unmute and you can ask the queries. The Professor Bindu Krishnan, madam.
Yeah, even though one more thing, actually, this is a simple basic thing, but I thought everyone who is planning to do it. Of course, nowadays in computer science, almost all are doing research in computer science, is machine learning as well as artificial intelligence. So we as teachers, now I can't say I am a teacher, but previously I was a teacher. But even as a teacher, actually, we need to know what is the thing behind that. So that is why I thought of sticking on to that some basic things. Okay, tell me any queries?
Participants, if you wish to communicate with the resource person, you can unmute yourself and interact, please.
Sure. Please.
Hello.
Yeah.
Good evening.
You're audible, sir. Please ask your query.
The algorithm that you have shown in the previous slide, all are based on statistical methods. So is there any true AI algorithm out of these?
Yeah, that's why I mentioned actually machine learning is only a sub.
Your voice is not coming, madam.
Am I audible?
Yes, you are audible, madam. See, your voice is clear. Just you have to check your connection, sir, please.
But
Madam,
your
please
voice is coming.
See, madam voice I'm able to listen. She is clear, actually. Yeah. Madam, please proceed.
Okay, so as far as machine learning techniques or algorithms are considered, basis everything, all algorithms I can say, I am not skipping any of the algorithms, all algorithms basic is mathematics or statistics itself. But while moving to AI, definitely there are many things without mathematics or statistics, sure, because machine learning is actually only a sub of artificial intelligence. Is it clear?
Madam, I'm having one question for you. Can you allow me?
Yeah, sure, please.
Madam, whatever your lecture was quite informative and useful one, and it was very clear. I wanted my question to you is that whatever all the analysis models are depends on the statistical analysis for the supervisor means this model supervisory. So we are getting perfect results from these models by analysis of these models, or it is trial or error basis, ma'am?
No. Actually, that's why I mentioned in statistics. Actually, we focus. Our aim is to develop theory, right? So always after developing theory, some origin will be there. Of course, some genesis is there for all the theory. So just to prove that, we use a low volumes of data, and definitely we will check goodness, so many goodness of fitness criteria there. So such as some of you may heard about the word term Kolmogorov-Smirnov statistics. So similar to that, so many goodness of fitness criteria there to claim that superiority of the model. But in machine learning, it's not like that. We always deal with large volumes of data. So definitely, while dealing with large volumes of data, we can expect some error. But there are techniques to avoid this error or to carry on how to be, because machine learning predictions always finally we will reach that performance, that prediction accuracy is this thing. If the prediction accuracy is 90%, remaining 10% will be error. But if you want to reduce that error of 10% to below 10%, criteria are there. So many criteria. Either one simple thing is you can use more training data. Then even a regularization technique. So many things are there. Okay, so that is the case. That is the difference between it. But in statistics, we are not using this regularization techniques or anything. Another thing is this regularization technique means, madam, are you aware of regularization techniques? Actually, two things are there: L1 and L2 regularization. L1 lasso regression, ridge regression. So there again, statistics came for rectifying that error, for reducing the error. Again, we are using the statistical techniques. But statistics actually we are not, I'm not saying that we are not measuring error, definitely we are measuring error, but that error will be less because based on the low volumes of data. Is it clear?
Yes, ma'am, but we are getting whatever you are telling that the results, whatever we are getting quite corrective one, but is there any such a correct model, standard model systems are there developed or standard model systems are there so that we can come to know that whatever results we are getting from the statistical analysis is correct one, ma'am. Is there such a method available, standard one, please?
No, actually that is why we are using different. See, if we are provided with data, first we will check whether it's we use, and if you are planning to apply, come up with a if you are planning to develop with a machine learning model, definitely first thing is that we will check whether our objective, that's a classification problem or a regression problem. Suppose it's a classification problem. So in the classification model itself, we have different machine learning techniques. So we will do, or we can apply, we can make predictions using different techniques. And definitely, before doing that technique, before applying the technique, we cannot say that this DAY5 is a suitable machine learning model for this particular data set. What we do is that we will apply DAY5, then logistic regression or other classification problems. Finally, definitely we will check the performance accuracy. Whichever model has accuracy high, we will adopt that model as the best model. Right? And there are various measures to reduce the error. There are various measures to reduce the error.
Okay? Yeah, madam. Is there any IIT or NITs are working on such algorithms, ma'am, to develop the algorithms or such a systems?
Algorithms actually, I suggest you to proceed with the deep learning algorithms. If you are dealing with the images, please proceed with the CNN, convolution neural network, which is again a deep learning algorithm. That will give a more high accuracy than the traditional machine learning algorithms. Okay. Any other queries?
Dear participants, if you want to wish queries, please ask. Okay, madam. They are clear with your PPT, maybe. Thank you, Bindu Krishnan, madam. Really, it is a very wonderful session. You shared more knowledge on machine learning. and you deeply explained what is machine learning and what is learning, and you give more examples, and you explained different types of machine learnings, and finally you suggest that different types of algorithms like deep learning and convolutional neural networks. So really, it is very helpful to all research scholars and faculty members, and I hope that they get more knowledge on this session, madam. Thank you very much, madam. Have a nice day. Thank you, madam.
Thank you all. Thank you, Kiran sir. Thank you, sir, for the opportunity once again.
Thank you, madam. Hope we will continue this collaboration in future endeavors also.
Okay, sure. Even though I moved towards industry, but this habit always I keep because I'm very much passionate.
Thank you, madam.
Okay, thank you. Thank you.
Have a nice day.
Yeah, thank you.
Dear participants, I hope that really you enjoyed these 5 days and you gather more knowledge on recent trends and cyber security. Do you want to communicate anything? Please communicate with us.